Good morning. This is Dr. David A. Padgett, Weather and Climate. Today is February 23rd, 2021. I'm going to share my screen and get right into today's work. Okay, here's the right section. Okay, so as you can see, this week is week 5, and so yeah, we're in the week 5 here, and so for some reason the week 5 schedule, all right, let's see, week 5, maybe my eyes aren't adjusting. Okay, here, no, I guess I had to refresh the page. Okay, so here's the week 5 schedule. And so again, today we're going to look at some article reviews and do the daily weather map report. And then we're going to share our climate PowerPoint presentations. And then we're going to get into a lecture on atmospheric systems dynamics. And then you will have, then we're going to talk about the term paper just a little bit, just to reiterate some of where we should be with that at this point in the course. And then we'll finish up with the assignment for this week. So that's what we'll be doing today and on Thursday. Okay, so as you all are probably well aware, article reviews, your first article reviews were due this week. And so let's see if we have, well, anyone who would like to share his or her article review. I guess nobody is here from that section. Of course, this is asynchronous, so it's not a requirement. Let's see if we have anyone from the other section. Article review 1. Okay, so please try to get those article reviews in as soon as possible. Remember, all assignments have a grace period of 12 hours. After that, you lose 10% or half a point, and then half a point for every 12 hours thereafter. So there's still plenty of time to turn in those article reviews. So an article review will be due every week. And so just to refresh your memory, let's go back to the course syllabus. And so those article reviews are part of your, a major part of the grade. So just don't forget to do them. The instructions are right here in the syllabus. And so there are the instructions. If you have any questions, please let me know. Article review is due each week. I think I went over the article review instructions in detail. Let's see, we do have I'll just take a look at what's been turned in thus far. I'm going to stop my share. Actually, I'm going to pause the recording. Okay, so we're back, and we're going to take a look at an article review that was turned in by Kaylee Rhodes. And so her article is about the impact of the snowstorms, ice storms, extreme cold that struck the state of Texas last week. So she looks like she cited the article in the correct format here. Then she has her article review 1, date, name, her major, and then she wrote about the article that she found and in detail, 250 word essay, and then 3 things that she learned from the article. And then her keywords: winter storm, good, Texas, the location, shelter, deadly. Yeah, those are good keywords. Like, think of a keyword as a word or phrase that you would use to find more articles like the one that you found. If you were going to do a Google search to find more articles about the winter storm in Texas, and you entered these keywords in, you'd probably find what you're looking for. So Rhodes did a really good job with that. We might revisit these article reviews on Thursday, but again, you still have time to turn them in today. If you have not, well, clearly many people have not done so. So just make sure you get those article reviews turned in, because they do count. If we go back to the syllabus again, the article reviews do count for a significant portion of the grade. So I scroll here through the syllabus and get to the grading scheme. We see here that here are your article reviews. 5 points out of 35. So that's 1/7 of your grade, which is pretty significant, so just make sure you get those done. Okay, so let's get back to the rest of our planned activities for the day. Oops. That's assignment 5. I meant to go to week 5. Okay, so the next thing that we're going to do, as usual, is take a look at the daily weather map report. And so we're going to look at weather map. If you notice, each week, I post I'm going to be posting the weather maps. And so the weather maps from last week are posted here. And again, on the midterm exam, which will be administered during midterm week or thereabouts, you will be responsible for being able to interpret these weather maps. So we're going to go back to content, and we're going to go to content, and then we're going to go to online weather resources. And the first link under online weather resources is the AMS data stream page. Click there, and we want to go to the map of isobars, fronts, radar, and data. There are other weather maps here that you can reference, but let's just look at this one. So here's today's weather map for February 23rd. And later on, I'm going to start to, I guess it's not fair for people who aren't here, but be sure that you can look at this map and interpret what is happening in the atmosphere in terms of temperature, barometric pressure, dew point, weather fronts, and so on and so forth. So that's what I'm going to be asking on the midterm exam. So Garrett Ross, where are you from? What do you list as your hometown?
Memphis.
Okay, so let's look at Memphis. Do we have a weather station for Memphis? We don't. Okay, so the closest one is, we'll use Little Rock, Arkansas. So for example, I would ask on an exam, what is the barometric pressure? And of course, you can either look at one clue is to look at this isobar. Remember, an isobar is an iso line that connects points of equal barometric pressure. And we can see that it's 1,020 millibars. Notice that when we get to Little Rock, Arkansas, it says with the weather station symbol, there's a 198. So that 198 means that it's 1,019.8 millibars. So if you want to check on your guess at the well, not guess, but I guess it is your analysis of the weather station data, look at the isobar that's nearby. Now, one of the things that we're going to learn later on in the course is, of course, what is, well, actually this week, is how do these atmospheric phenomena affect weather? So, for instance, why do we look at barometric pressure? Like, why is that even important? It's not as if we're sensitive to it, right? It's not as if you can feel the weight of the atmosphere on any given day. It's not as if we can see it. I mean, we can see clouds. I mean, it's obvious why we might look at cloud cover percentage. I mean, that gives us an indication of perhaps what kind of activities we might want to participate in on a given day. And so, as you can see at Little Rock, Arkansas, the sky is clear at this weather station today. Now, notice that this is Jackson, Mississippi. This looks like Oklahoma City, Oklahoma. Notice that, and also at New Orleans, Louisiana. This looks like it might be Lafayette, Louisiana. Also El Paso, Texas, San Diego, California, Los Angeles, California, Sacramento, California. There's kind of that's Bakersfield, California. Notice there's this kind of double circle. That means that winds are calm. There's no wind, no measurable wind being detected. Of course, at Little Rock and at Nashville, we can see clearly that there's some light winds coming out of the west. Also, we can see that there is high pressure dominating this region. Notice high pressure is normally associated with very clear skies. And we'll talk about why that is later on. Okay, let's look at some of the frontal boundaries. Okay, here's something that's interesting. So up here in Canada, notice there's that L, that stands for a low. So we have a low. That means that that air is rising. And so as air rises in the atmosphere on Earth, for a variety of reasons, that rising air rotates around the low in a counterclockwise direction. So here we see these fronts. If you can imagine that low, the air is spinning around that L. And here we have warm rising air behind this warm front that is coming and is circling around that low pressure system. Here we have colder air coming from the north. So what is probably happening? And when you start to look at what's happening in practice, we have to go back to our discussion earlier when we were discussing North American air masses. And so we look at these air masses, those frontal boundaries actually represent the leading edges of these air masses. So these air masses move around. due to Earth rotating and moving through space. You know, you have to understand the Earth is rotating on its axis at close to 1,000 miles per hour. So even though we're not sensitive to it, the Earth is rotating on its axis at 1,000 miles per hour. And the Earth is hurtling through space at 58,000 miles per hour. So there are a lot of dynamic forces that are acting upon us that we're not sensitive to at all, because for a lot of reasons, including the gravitational force and so on and so forth. If we were sensitive to these forces, there would be, I don't think there'd be any human life on Earth, obviously, or maybe no life. You know, if we actually could feel 58,000 miles per hour friction. But we don't. We have no idea. But of course, those forces act upon the atmosphere, and those winds and other forces, you know, move around and move these air masses around. And so every now and then, this continental Arctic air mass will move to the south. And when I say every now and then, I'm maybe once every 20 or 30 years. And we get that situation that we had, or are still, people are still experiencing this week, even though most of that cold and ice and snow occurred last week. And so it's very, very uncommon for that kind of very cold air to move that far south. Now, conversely, there are times when this maritime tropical air mass moves towards the north. And that's somewhat what we're seeing here. So we can see, let's look here. So in Green Bay, Wisconsin, it appears to be 36 degrees Fahrenheit pretty early in the day today. So that's very warm for this time of year. I mean, look, if we go as far north into Canada, 30 degrees Fahrenheit. Chicago, Illinois, 39 degrees Fahrenheit. Now, I know that to us in Nashville, that seems kind of chilly, but 39 degrees Fahrenheit in Chicago in the middle of winter, and fairly early in the day, is that's pretty warm, you know. And so we here in Nashville, if you notice, we're at 52 degrees Fahrenheit already today. So clearly, if I was to ask you on an exam, what air mass do you think is influencing the weather at your select given city? You should be able to answer that question. So in this case, it would be most likely the maritime tropical air mass. It's warm. Now, what might throw you off a little bit, the temperature is a dead giveaway. Another dead giveaway, perhaps, is um, is the dew point temperature. So the dew point temperature is the temperature at which condensation takes place. Clearly, it's 52 degrees Fahrenheit ambient temperature. The dew point temperature is at 27 degrees Fahrenheit, very far apart, which means that there's very little chance of rain in Nashville today once you see the difference in those numbers. Uh, Now, ordinarily, you would think, well, the maritime tropical air mass um, would be very moist, perhaps. But obviously, there's a different influence occurring here. And so we have this back and forth. Here is if you look here, this air mass cold front, this is the cold front that probably came through last week, or maybe late last week. So that's that last part of that cold front. It's offshore now. It's moving into Florida. And so let's look into Florida, and it's 68 degrees Fahrenheit in Tampa. That Well, for people who live in Florida, that's pretty chilly. Um, Believe it or not. But who knows if that temperature is going to stay that way. Uh, Interestingly enough, Florida has had its coolest winter in about a decade. It's been, if you've um, paid attention to weather in Florida, it hasn't been as warm as it normally is during the winter. It's been in the 70s. I mean, even into South Florida, which usually is, you know, consistently in the 80s, mid 80s, but not this winter. Not this winter. The Tampa Bay area has been relatively cool. So this is today's weather map. I'm going to save this weather map before I forget to save it, which is something that I tend to do sometimes. And at some point, this is February 23rd. So I'm going to be posting these weather maps. And again, you on the midterm exam are going to be asked to interpret these maps. In the course materials, I have posted, this is from the week 4 schedule, if you remember. Um, there's the weather map symbols here, and also this PowerPoint presentation, weather data acquisition and forecasting, also has a a quick tutorial on how to read weather maps. So that is today's weather report, and so just get used to being able to interpret those weather maps. You should be able to make certain predictions about what's happening in a given city. Okay, so back to today's schedule. This week, you all were assigned the task of reporting out on your individual city climate. So I'm going to pause the recording for a moment. Okay, we're back, and we're going to take a look at one of the PowerPoint presentations that was turned in. Hopefully, we'll have more on Thursday. So once again, there is a 12-hour grace period on all assignments, including this one. And so just try to get it in as soon as possible. So let's go back and look at the instructions again as a refresher. So you would produce a 10 to 12 slide PowerPoint presentation describing the weather and climate of your hometown cities. It must include maps, graphics, and data. You can include anecdotal and qualitative data, and I gave you some places to look for weather data, and we talked about where to find climate data. Okay, so let's see what Kaylee Rhodes turned in. So she has 10 slides. That's good. So she starts off good, just like I instructed. Nice title, name, major, perfect. So she's starting off with climate. So I'm assuming these are good average. So this is, again, climate. You look at atmospheric conditions. She has a map here, very good. She even threw air quality in there. Now, air quality says 50. That's the air quality index, actually, and there should be an explanation for what that number means, but that's fine. Everything else does have units. I guess this 196 is 196 out of 365 sunny days per year. I'm assuming that is what that means. So always include your units when you are making a quantitative expression. So here we have, she's found some rainfall data. So this would be more climate data. And so we have average amounts of precipitation throughout the year. And this is monthly precipitation. And she has a little explanation. And at least here, there's a little bestplaces.net. So if this was in a term paper, at least we know that at least we know the source of these data. Very well done here. Snowfall, more data from bestplaces.net. And that's probably not the best source, but it's okay for this. I did say this is a qualitative thing. Qualitative data was okay, even though this is quantitative. But I'm sure that bestplaces.net sourced another site. So this technically is not primary source data. This is secondary source data. Bestplaces.net is more of a media outlet. You know, bestplaces.net does not collect weather and climate data themselves. They referenced another source. So this is a secondary source, but that's fine. I mean, that's fine for what we're doing here. So snow days, and then she has the 5-day forecast for this week. That's exactly what I was looking for. Monday, weather to okay. Well, the only thing that is missing from the presentation is that there's no notice that I did not put in there a requirement. I guess if she had actually presented this, or he could be, I don't know, Kaylee, I don't know. But if this was actually presented, I guess there would have been some discussion, fill in, or some summary or summarization of the data on the PowerPoint. So I guess I can just say that that's still okay. And so Kaylee did exactly what was asked. Bullet points here. It would have been nice to actually see this presented, but okay. But I would like to see a little bit more first person anecdotal information, such as, I don't know, just a little bit more text and description to go along with what's on the page, but that's fine. So for example, here, notice you have the graph, and then, well, I guess this isn't original text, but anyway. So that gives you somewhat of an idea of what's expected. And what this is setting you up for as we move into the next portion of our day here. What is this? This is setting us up for, you up for, or let me be more specific. What this assignment is setting you up for is getting you into the first portion of the term paper assignment. So on the schedule, as I mentioned, now we're down to a discussion of the U.S. city climate comparison term paper, which is again described in your syllabus. And so if you are planning, speaking of the term paper, if you're planning a career in teaching, let me know. I know what most of your majors are, and what some of your majors are here. I haven't been able to meet everyone, but please, if you are planning a career in teaching, let me know immediately via email or some other means, because you will be assigned a different term paper format. So here is the hometown climate data analysis term paper format that's in your that's in your in the syllabus. So let's just take a look at that again. I will be giving you frequent reminders in here, as you probably have figured out by now, just to keep this information on your radar. So again, the term paper, the hometown climate data analysis term paper, says the main objective is to gather atmospheric data from various sources in order to analyze the climate of your home city. So, excuse me. So this assignment, and this is what I mean by more text. I did say I didn't want you to write paragraphs, but there should be some bullet points listed in your PowerPoint that summarize the general nature of the climate of your city. Okay, that should be in your PowerPoint, because that'll get you started towards completing section 3. So describe the climate of your city in terms of number of sunny days per year, snowfall, precipitation characteristics, wind, air quality, natural hazards, extreme events, et cetera, et cetera, et cetera. Just a general description. If you were to tell somebody, if somebody was moving to your city and they ask, what's the climate like there? What would you say? Now, not just your opinion. Oh, it's cold. Remember, you need to have some data to back up whatever it is that you say. And so in Kaylee's case, she used bestplaces.net, which is okay. I would rather have you use some of the resources that I provided on the website, and there are lots of them for you to use. And we'll get into more climate data as we get deeper into the course. So you should be working on section 3. Now, at some point very soon, I'm going to ask you to turn in a draft for a grade. I want everyone to keep up turning in sections of this paper, so we're not trying to do an entire term paper in the last 2 weeks of class. We've all done it. I'm trying to prevent that scenario, because usually you turn in a paper that is not your best work when you try to cram it all in during the last week of class. That's hopefully not going to happen in here. And then, of course, your area description is just a general description of your city in terms of land use. Is it heavily urban? Is it a small city? What's the population? What's the terrain like? Is it hilly? Is it flat? What's the elevation? The hydrology? What are the major bodies of water? Is it swampy? Is it very dry? Is it what are the soils like? Vegetation? Is it find the vegetation pattern, et cetera, et cetera. And you should include maps of the city and photographs of pertinent features such as mountain ranges and so on and so forth. So this assignment was meant to move you along towards the first and second portions of the term paper. So it kind of is a two for one. Okay, so now we're down to the last part of the assignment, which is the third part is atmospheric systems dynamics. I kind of skipped over that. So today I've kind of alluded to some atmospheric system dynamics. And so some of the things that you will need to know that are important on the midterm are first is layers of the atmosphere and composition of the atmosphere. So let's start there with layers of the atmosphere. And so let's go to layers of the atmosphere. Okay. That might be back at week 4. Okay. Okay, I'm going to stop recording here. Pause. Okay, I'm going to resume recording, and sorry about that. You share my screen. Things happen. These things happen to the best of us. Okay, so we are going to look at layers of the Earth's atmosphere. So there are several layers of the Earth's atmosphere. The most important for us is the troposphere. So as you can see on this graphic, the troposphere goes from the Earth's surface up to about 6 miles or 10 kilometers above mean sea level. That's where we human beings spend almost all of our time, unless you happen to be an astronaut or fly on a plane. But most of the time, all of our weather occurs in the troposphere. The air we breathe in is in the troposphere. All that's in the troposphere. So that's probably the most important layer of the Earth's atmosphere for us. And so let's see if I can. So next we have the stratosphere, which this is a very good diagram. So this is the stratosphere, which goes from about 10 kilometers to 50 kilometers above the Earth's surface. This is where we find the ozone layer, the naturally occurring ozone in the atmosphere that blocks those ultraviolet rays from reaching us and impacting our skin cells. So that's the good ozone that's in the stratosphere. When we humans, through our human activities, create ozone through pollution and elevated heat, tropospheric ozone is bad. That's the ozone that triggers asthma attacks and causes people who have respiratory problems to suffer. Uh, Tropospheric ozone is very bad for us. But now if you notice this red line, this is a very good diagram. This red line represents the temperature as we move. So you can barely see it. So it says temperature degrees Celsius. It's very hard to see there. So notice here at the surface on this particular diagram, the surface temperature is at 20 degrees Celsius. But by the time we get to 10 kilometers above the Earth's surface, now that temperature is minus 60 degrees Celsius. So in general, as we move away from the Earth's surface in the troposphere, the Earth's atmosphere gets colder. You probably already knew that. And we're going to talk about that later on today, or maybe Thursday. So what happens is, of course, as we move farther away from the Earth's surface, the gravitational pull of the Earth becomes less, has less of an effect upon the gases in the atmosphere. And so when there's less gravity affecting atmospheric gases, those gases expand. When gases expand, they cannot hold heat as well as when they're closer to the Earth and are more dense. And so that's why we see this cooling effect. Now, notice when we get into the stratosphere, the atmosphere gets warmer as we move higher into the stratosphere, and that is because of the ozone layer. So the ozone layer absorbs those ultraviolet rays, and that results in a warming as we get higher into the stratosphere. Then, of course, when we get into the mesosphere, then those temperatures begin to cool. And in the thermosphere, we're very far away from the Earth's surface, 50 miles up, and now that's basically into outer space. So those are the various layers of the atmosphere. I don't know where this link, I found it. just add this link to the to today's links. I have no idea where that link disappeared to, but let's toss that in here. Create link. Boom, paste, boom, boom. Layers of the Earth's sphere. And I have to remember to copy that to the honors section page also. Okay, so we've added that. So very important that we understand the layers of the Earth's atmosphere and their properties. Next, composition of the atmosphere. And so I know exactly where that is. That's at week 4. And so under week 4, we find the gaseous composition of the lower atmosphere. This is below 80 kilometers. So unbeknownst to many, the Earth's atmosphere is not mostly oxygen, it's mostly nitrogen. Almost 80% of the gaseous composition of the Earth's atmosphere is nitrogen, about 21% is oxygen. So if you notice, that is almost 100%. So the rest of that Earth's atmosphere, which is less than 1%, basically is comprised of all the other gases, carbon dioxide, methane, and so on and so forth. When we start to talk about greenhouse gases, such as carbon dioxide and methane, it should bear to mind or come to mind that, wow, especially with carbon dioxide being a very influential greenhouse gas, the question may come to mind as to, well, wait a minute, if carbon dioxide is such a tiny constituent of the overall volume of gases in the Earth's atmosphere, how can it cause all these changes? How can that small portion of the Earth's atmosphere, if we get a little bit more of it, cause global warming and climate change and all these catastrophic phenomena that we keep hearing about that are associated with global warming and climate change? We'll talk about that later in the course also, but you should be aware of the composition of the Earth's atmosphere. And so let's go back to our week 5 schedule and march through more of what you need to know. Okay, air masses, we've talked about air masses. Weather fronts, we've talked about warm fronts, cold fronts. Maybe I should get into more detail. Let's get into this frontal weather PowerPoint presentation here. I've talked about frontal weather a lot, but you should familiarize yourself with some of the characteristics of weather fronts. And so remember, weather fronts are essentially represent the fronts of these various air masses. And so again, air masses meet at fronts. So that's what you should understand. So here is a schematic view of a stationary front. And so if you notice, the symbol is the little half circle red on one side and the blue. That's the cold front. So here we have cold air here. Warm air, notice the warm air rises up over top of the cold air. Now, stationary front, notice is stationary. So under these types of conditions, this is where you have perhaps a rain, a rain, not, I wouldn't say storm, but a rain event that might last for a long time. A day when it rains all day, or maybe if we have a stationary front, where it rains for several days. You know, that's because it's not moving. This warm air is rising above the cold air when the warm air cools. Now, as this warm air moves away from the Earth's surface, it cools off, reaches its dew point. We start to see clouds. So those clouds start to um, produce rain. Now, notice that you have these little symbols here that represent the types of clouds that form under certain conditions. Notice that the clouds here are stratus, cirrostratus, altostratus. And so when we get into cloud nomenclature, as you saw when you did the globe exercise, different clouds have different shapes or are named because of their shape. So the stratus clouds are the flatter clouds, okay? Flat clouds. And so not the puffy mashed potato clouds. Puffy mashed potato clouds are cumulus clouds. But notice at a stationary front, when there's not a whole lot of motion, you have relatively stable conditions, and so you tend to have these flatter clouds. And of course, as clouds are named based upon their shape and how high they are in the atmosphere. So this is a stationary front. And so here's some of the characteristics of stationary front. And here's a warm front, somewhat similar to a stationary front, as you can see. Um, but again, warm front, slow moving, warm air rising up over cold air. You see the direction of the front. And of course, we have, notice the nimbo prefix, that's nimbostratus. Nimbo means this is a rain producing cloud, a rain producing stratus cloud in this case. And then, of course, the very high clouds are the cirrus clouds. And cirrus clouds are sometimes made of ice crystals because they're so far above the earth, not water droplets. And so you see here, a warm front is usually associated with a wide area of precipitation, if there is precipitation. Uh, this is where you'll see a swath of precipitation occurring over an entire region, maybe over the entire south of the United States. Uh, whereas with the, so here's some warm front characteristics that you should familiarize, like somewhat similar to a stationary front. Here are the clouds. Now, a cold front, cold air is more dense and moves more quickly. So when a cold air mass encounters a warm air mass, it's a much more, can we say, violent collision, where that warm air, as you can see, is forced very quickly up into the higher portions of the atmosphere, and we start to see these cumulonimbus clouds, otherwise known as a thunder cloud. So those cumulonimbus clouds are associated with cold fronts. That's where we get thunderstorms and tornadoes and all the kinds of things that we see occurring at these frontal boundaries between cold and warm air. Notice the clouds now are cumulus, alto cumulus, cumulus, those puffy clouds that are indicative of unstable conditions and storms. And in many cases, these cold frontal boundaries exhibit what we call storm cells. This is when we have those lines of storms and they move very quickly. Again, they're often associated with tornadoes, extreme weather. And so here's some of the characteristics of a cold front. And we've been talking about fronts. Here's some of the map symbols. And so you can kind of see how these fronts are symbolized on maps. Now here's an occluded front. We talked about an occluded front. And so an occluded front is symbolized by, well, we'll see that later. But as you, an occluded front is when you have more than one air mass in an area. So you might have a cold front, cooler weather. They both force this warm air above. And you can see a mixture of precipitation types here. There might be thunderstorms, and then you might also have widespread rain and a mixture of clouds. So this would be an occluded front. So here's a warm front occlusion, and so on and so forth. So those are the various characteristics of weather fronts, and we'll be talking about weather fronts throughout the semester. We're really every day when we look at our weather map, we will be looking at various frontal boundaries as we saw today. I don't see, this is a stationary front here, stationary front there. I don't see an occluded front. Maybe there's another day we'll see that. So forms of precipitation. So I did promise you that we would talk about various forms of precipitation. And so here are the various forms of precipitation. So there's rain, of course, which is liquid precipitation. Now, remember, I said that condensation is when water vapor converts to liquid water. And so condensation has to take place upon a surface. So when you shower in the morning or whenever, and you notice that fog on the mirror, that's condensation. So water condensates upon the mirror. But in the atmosphere, well, what's the surface? What provides a surface for condensation to take place? Well, dust particles. That's where water, that's where raindrops form, is around particles of dust in the atmosphere. So the more particles of dust there are in the atmosphere, the more likely it is that we're going to have rain under the right conditions. So that's liquid precipitation. Okay, next there's freezing rain. Freezing rain falls in liquid form. And so water can actually be in liquid form below 32 degrees Fahrenheit or 0 degrees Celsius. A lot of people don't realize that. 32 degrees Fahrenheit is the melting point of ice. That's what that number is. It is not the freezing. It is close, but it's not necessarily the freezing point of water. And so, yes, water can fall to Earth in liquid form colder than 32 degrees Fahrenheit. And of course, if the ground surface is also cold, that water will solidify on contact. And so that's and that causes very dangerous conditions. The black ice you see on the highway. So a person might be driving and you see that the rain it looks like it's just regular rain, and it's freezing on contact on the road. A road might look like it's just slick. It's actually a sheet of ice. And that's how people get into all kinds of horrible accidents, because you're driving the same rate of speed that you'd be driving if it was just raining, which for some people is, they don't slow down at all. Whereas if it's snowing and you can see the snow, then you're going to take your time, hopefully take your time and slow down. And I can see this white stuff on the road, but the black ice, it looks normal, and you end up sliding off into a ditch. Now, sleet is also solid form of precipitation, but sleet is when precipitation falls in a solid form. And you can see sleet, you can hear sleet bouncing up off your windowsill or hitting your windows of your cars. You can actually hear and see sleet. It's these balls of ice. So sleet is a wintertime cold weather type of frozen precipitation. Hail, on the other hand, forms specifically in cumulonimbus clouds. And so what happens with hail is water maybe begins to fall to Earth in liquid form, but through convectional processes, either through frontal lifting or through convectional lifting, gets pushed higher in the atmosphere. And when it gets higher in the atmosphere, that water freezes, then it tries to come back to Earth, and it might get pushed back up. And the more times that hail ball gets pushed up, the larger it gets until it falls to Earth and can cause a lot of damage. Now, snow is also frozen precipitation, but snow forms via deposition. That's when water goes from a gas to a solid without ever becoming a liquid. And when that happens, crystallization occurs, and we call those snowflakes. So these are the various forms of precipitation. And we'll talk about these at various times throughout the course. I just wanted you to understand that, especially with these frozen types of precipitation, a lot of people use these terms interchangeably, but hail and sleet and freezing rain are not the same. Okay, so that is just one thing that I want to get across there. Let's see, how are we doing? We're at quarter of, so we can probably so we will get into the Hawaii lapse rates exercise in greater detail next week, or not next week, on Thursday. However, if you wish to start on the Hawaii lapse rates exercise, let me go to student view. All right, student view. So, yeah, I would, take a shot at it. We'll talk about it in greater detail, but here are the instructions. Essentially, we are going to, here are the instructions for the Hawaii lapse rates exercise here. It is somewhat challenging to understand. I will walk you through it, but if you can, figure out what to do. Now, you're going to have to draw a schematic profile using pencil and paper. So this is not going to be your typical assignment. So you're going to have to draw, maybe by Thursday, at least draw the schematic profile of Mauna Kea. And then we'll work through the rest of the assignment on Thursday. But if you can, at the very least, draw the profile of Mauna Kea according to the instructions, then you'll be well on your way to completing this exercise. So that is the exercise for this week, again, along with the along with article review 2. Again, if you have not completed the article review assignment for this week or the PowerPoint presentation, please get that done. Again, you do have a 12-hour grace period before you start losing any points. And so make sure you get those done as soon as possible. Again, if you have any questions, let me know. And I'm going to stop recording now. Have a nice rest of the day.